So today we are discussing about the moment of inertia. So the term inertia was given the term inertia was given by Galileo, but it was used by Newton in second law of motion. The term inertia was given by Galileo and it was used by Newton in second law of motion. What is inertia? Inertia is a quantity of matter. It is a quantity of matter or the property of a body which is in a rest and changing in states to be tried to be in the motion. Or we can say a property of any body which is in rest and changes its state from rest to motion or tried to be in motion is called inertia. So the property of the property of body in rest to change its state or tried to be in a motion is called inertia, not a moment of inertia. We are discussing here called just inertia, just called inertia. Here it is just called inertia, not a moment of inertia. Okay, here it is just called inertia, not a moment of inertia. So consider an example. So there is a ship. Wait. Consider two ships. One is small and one is big. They are on the water. There is a one man sitting in this and one man sitting in this. When a man is pushing, जब एक आदमी sailor कश्ती को चला रहा है, so the small one have less mass, okay, and this will have more mass. According to this is the small ship have less mass and the large ship has more mass. So because of the more mass, its acceleration will be more. With more acceleration, its deceleration will be also very high. जितनी उसकी acceleration होगी उससे ज़्यादा उसको resistance force उसकी resist होगी by the opposite force of acceleration by opposite force by deceleration, which is known as deceleration. ये एक force है, ये एक body move कर रही है, उसने एक कश्ती से उसने चलाया और body move करी यहाँ तक और उसको रोकने में टाइम लगेगा because a heavy mass, उसका मास बहुत ज़्यादा है. अगर हम इसको कंपेयर करें, इसको अगर कोई बंदा चला रहा है, ये जाएगी कम और ये रुक भी जल्दी जाएगी. So this states that moment of inertia or either inertia is inverse relation with mass, have an inverse relation with mass. Inertia is also called as mass. There's a word, first law of motion is also known as law of inertia. First law of motion is also known as law of inertia. So inertia depend upon the mass. If mass is higher, inertia low. If mass is low, inertia will be more. अगर किसी शिप का इसका मास कम है सो इसका इनर्शिया ज़्यादा होगा. मोर इनर्शिया, लेस मास, more inertia. And if you see this, more mass, less inertia. Okay, more mass, less inertia. More mass, less inertia. So these are the two examples which shows the inertia, in which there are higher inertia and low inertia. जिस भी बॉडी में ज़्यादा मास होगा उसमें इनर्शिया कम होगा, जिस बॉडी में ज़्यादा मास होगा उसमें इनर्शिया कम होगा, जिसमें कम मास होगा उसमें इनर्शिया ज़्यादा होगा. Okay, now consider another example. There is a fan. There are two fans. One is smaller, एक 3 परों वाला है, एक 4 परों वाला. So this is the smaller fan, this is the large fan. अगर हम ये suppose it's moving, ये चल रहा है, हम इसको बंद करें, दोनों चल रहे हैं, हम दोनों को बंद करें तो ये पहले रुकेगा और ये ज़्यादा देर तक चलेगा, थोड़ी देर के बाद रुकेगा. Why? Because it has low mass, उसका इनर्शिया ज़्यादा है, कम मास है. इसका मास ज़्यादा है, इनर्शिया कम है. मास ज़्यादा, इनर्शिया कम है. इनर्शिया बेसिकली resist the angular acceleration. Inertia just resist the angular acceleration. तो इसका मास कम है, ये जल्दी रुक जाएगा. इसका मास ज़्यादा है तो इसको टाइम लगेगा रुकने में. इट विल बी मतलब ये ज़्यादा देर घूमेगा और ये जल्दी बंद हो जाएगा. So these are two examples. I hope you got your concept will be clear about the inertia. So what is the moment of inertia? Moment of inertia can be defined as the property of a body resisting angular acceleration the property of a body resisting angular acceleration, which is the sum of all mass and square of a distance along axis of rotation, So the property of a body resisting angular acceleration, when angular acceleration resist कर रहा है, which is the sum of all mass and the square of the distance along the axis of rotation, is called moment of inertia. It is called moment of inertia. It is called moment of inertia. Moment of inertia. So what are the factors which affecting moment of inertia? So the factor dependent, the moment of inertia depends upon the factor we can say. So the factors include shape and size of body, density of a body, and axis of rotation, or distribution of mass, These are the three factors on which the moment of inertia depends. ओके, एक्सेस साइज एंड शेप वी नो दैट अगर साइज बड़ा होगा तो उसका मास ज़्यादा होगा, डेंसिटी साइज और शेप, अगर अगर उसकी शेप हार्ड है, शेप पे डिपेंड करता है। इफ़ साइज एंड डेंसिटी उसकी ज़्यादा है तो ऑब्वियसली ज़्यादा मास होगा, मास ज़्यादा तो इनर्शिया कम, इनर्शिया ज़्यादा तो मास कम। ओके, एक्सिस ऑफ रोटेशन की कैसे, सपोज कंसीडर अ रॉड, ये एक रॉड है, इस पर दो बॉडीज हैं, ये M1 and M2, M1 and M2, दिस इज द सेंट्रल पार्ट, ये है एक्सिस ऑफ रोटेशन। ओके, बॉडी के मास जो है वो एंड ऑफ द रॉड लगे हुए, सो इट कैन इजीली रोटेट, ये इजीली रोटेट हो सकती है, इसको फोर्स कम लगानी पड़ेगी, इसकी इजीली रोटेशन हो जाएगी। इफ़ अगर ऐसी एक है रॉड, उसका बिल्कुल मास इज अटैच्ड नियर टू द एक्सिस ऑफ रोटेशन, तो इसको ज़्यादा फोर्स लगानी पड़ेगी और ये कम रोटेट होगी। सो बिकॉज ऑफ दिस के एक्सिस ऑफ रोटेशन लंबी होनी चाहिए, दिस इज द डिस्टेंस r, दिस इज द डिस्टेंस r, सही, दिस इज दीज आर द लेंथ और रेडियस ऑफ द डिस्टेंस, सो r स्क्वायर, सही। कंसिडर टू रॉड्स, बीच में सेंट्रल एक्सिस है, दोनों सेपरेटेड है, इन द एंड ऑफ द कॉर्नर पे है, तो दे कैन रोटेट इजीली, सो दे हैव अ डिस्टेंस r, okay। Now the most of the in the MCQs the statement जो आती है in block moment of inertia क्या आती है, the product of mass and square of the distance, product of mass and square of the distance along the axis of rotation is called moment of inertia। okay, the product of mass and square of distance along axis of rotation, along the axis of rotation, along the axis of rotation. So product of mass and square of the distance along the axis of rotation. So by this definition we can write the formula that I is equal to m r power 2, m r power power 2. Just consider this 2 as a square. So I is equal to mr square, the product of mass and distance along the axis of rotation, square of the distance along the axis of rotation. Okay, so the unit will be if we determine unit, so I is equal to kilogram meter square, and the dimension will be m1 L2 T naught, T0 means this TO consider as a T naught, m1 L2 T naught or ml2 T naught is the dimension of moment of inertia. We know that moment of inertia, moment of inertia totally depends upon mass, totally depend upon totally depend upon moment of inertia totally depend upon the mass. So we can say dimension